my name is Ricardo, and I'm here with Math Matters, and today we're going to discuss probability, and especially the probability associated with playing the lottery. I'm using the Mega Millions, and in the Mega Millions, just a cool tidbit, the way that game is played is there are 6 numbers you have to choose. 6 different probabilities, six different probabilities to make up the giant probability. And the first number is out of 75 times the next 5, which are all out of 75. Rather sloppy, but the first 5 are out of 75. If you get all these right, and you're still not getting the jackpot, because there's a Mega Ball, or the Mega Millions special number, which is out of 15. So there's another number out of 15. And if you get all of these right, we multiply it because probability of all of them is probability of 1 and the next and the next and the next, which is multiplication. Multiply them all out, you get, the odds are about 1 divided by 34 billion, or 1 in 34 billion tickets. Now, that would mean about 146 tickets purchased per each legal adult in the United States. And that makes no sense, because no one buys that many lottery tickets, and definitely not that many lottery tickets are sold, because that's more than the amount of people in the world, 34 billion. So this is a huge, insane probability by itself. But luckily, it's eased down on you. It's not out of 34 billion, it's out of 258 million. 258,890,850 to be exact. So the odds are 1 in about 258 million, 259 million. That's because 259 million tickets are sold. It can't be out more than that if there's only that many tickets and somebody won, right? Or somebody's winning. And this is a lottery that already happened, so yes, somebody did win out of these 259 tickets. So when I say 1 in that many, this is the number that's important. The 1 in is obvious because there's only one ticket that wins out of this. So I'm just going to say 1 in from now on. Now 1 in 259 million. That means 259 million $1 tickets were bought. So if you spent $1 million, you would have 1 million chances, and that's still 1 in 259, 1 in 258. So it's not a guarantee. You would spend $1 million in lottery tickets and be nowhere close to the lottery. But the jackpot, so lottery jackpot is what I meant, but the lottery jackpot is not it, right? You could also win lower prizes. In fact, the second prize is $1 million. Hey, $1 million is not bad, right? But the probability of winning the jackpot is so very low that when we calculate the expected value, probability times the jackpot, it really doesn't contribute to the expected value, to the total expected value. So, for a calculation of the expected value, we do probability times the value. Now, the value in one of the highest record lotteries ever, Mega Million lotteries, was $636 million. So $638 million jackpot. Multiply that by 258 million and all the other probabilities. So everything from 636 million to, I believe there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 options that you can get, and the lowest being you get $0, right? So you can get 0, 1, 2, 5, 5, 10, 50, 100, 5,000, etc., 50,000, a million, 636 million. All these options. Now, it's very interesting to think that the 10th option, x of 10, which equals $0, has a 93% likelihood. So it's not even 1 in something, it's just 93% of the time. I mean, it is 1 in something, but the number's not as nice and not as compelling as saying 93% of the time you get absolutely nothing. And this is actually losing $1. You don't just get nothing. You spent $1 and now you lost it, and it's gone. So when we calculate the expected value, this falls to not only to 0, but to -1. Because the expected value is your profit, right? How much would you profit from this? You'd profit $1. So therefore we're going to do the expected value. I'm going to call it EV, which is probability of 1 times x of 1 all the way to probability of 10 x of 10. So this is 1 in 258 million over times 636 million, plus something else, plus something else, plus something else, all the way to -1 times 0.93, right? So it turns out your expected value for this record high lottery, this is, if you're ever going to invest in the lottery, this is the time to invest, is $1.62. $1.62. That is more than $1. So if you want to invest $1 in that, you're gonna have a profit, and that's a very compelling argument, and people pay attention to that. That doesn't slip by unnoticed. People notice that. Now, let me clarify. If you disregard the lottery, if you disregard the lottery jackpot, rather, if you disregard the jackpot, take away this first term, the expected value of the rest, let's call it EV2, is about like 82 cents. So yeah, the jackpot matters. If you ignore the jackpot, it's very unlikely that you're going to ever invest. But, so why don't people invest? Why don't people invest in the lottery? Why isn't that something that you've heard about? Well, it's because people don't invest in that lottery. Because the lottery is offered in 2 payment options. You can either get about a 30-year annuity, which means you get a smaller sum every year for 30 years, and therefore you can't really count your profits as 636 million. It's more like that divided by 30, how much you get in 1 year. Or you can take it right away, and you get about half of it. So getting about half of it, and once we realize how important the jackpot is, getting about half of it is pretty depressing, because now when you calculate your expected value, the jackpot is half of what it used to be, and it takes away quite a bit of your earnings. In fact, your expected earnings goes down to about, let's see, $0.49. So, without the value of the Mega Millions at 636 million, and instead it shows here you would get about 341 million, the expected value is only 49 cents. Now, it's still a viable option, but the profits you get are not nearly as satisfying as $1.62, and because we compensated for the $1 that you spent buying the ticket, this 49 cents is not even half of that. So getting a profit that's not even half of what you invested, and if you bring this to the millions, investing millions of dollars, getting a profit of not even half of what you invested is not something that's worthwhile, and that's why people don't really invest in the lottery. Hi guys, thank you so much for watching my video. It really does mean a lot. And if you enjoyed this one, I encourage you to watch the next video of my series. And hey, if you're done with the series, there's always more mathematics to learn. Because remember, math matters.